Hello everyone, this is Sarvahita, Assistant Professor of CSE Department from Rohini College of Engineering and Technology. I'm here to discuss a topic from cloud computing. The topic we are going to discuss is about the security standards. Security standards define the processes, procedures, and practices which are necessary for implementing a security program. These standards also apply to cloud related IT activities and include specific steps that should be taken to ensure a secure environment which is maintained that provides privacy and security of confidential information in a cloud environment. Security standards are based on a set of key principles intended to protect this type of trusted environment. Messaging standards, especially for security in the cloud, must also include nearly all the same considerations as any other IT security endeavor. Now let us see about the security which is implemented in SAML, OAuth, OpenID, SSL or TLS. A basic philosophy of security is to have the layers of defense, a concept known as defense in depth. This means having overlapping systems designed to provide security even if one system fails. An example is a firewall working in conjunction with an intrusion detection system, which is commonly called as IDS. Defense in depth provides security because there is no single point of failure and no single entry vector at which an attack can occur. No single security system is a solution by itself, so it is far better to secure all systems. This type of layered security is precisely what we are seeing develop in the cloud computing. Traditionally, the security was implemented at the endpoints where the user controlled access. An organization had no choice except to put firewalls, IDSs, and antivirus software inside its own network. Today, with the advent of managed security services offered by cloud providers, additional security can be provided inside the cloud. Now let us see about SAML, that is Security Assertion Markup Language. SAML is a XML based standard for communicating authentication, authorization and attribute information among the online partners. It allows businesses to securely send assertions between the partner organizations regarding the identity and entitlements of a principal. The Organization for the Advancement of Structured Information Standards, that is OASIS, Security Services Technical Committee is in charge of defining, enhancing, and maintaining the SAML specifications. SAML is built on a number of existing standards, namely SOAP, HTTP, and XML. SAML relies on HTTP as its communication protocol and specifies the use of SOAP. Most SAML transactions are expressed in a standardized form of XML. SAML assertions and protocols are specified using the XML schema. The versions 1.1 and 2.0 use the digital signatures based on the signature standard for authentication and message integrity. XML encryption is supported in SAML 2.0, though in 1.1 it does not have the encryption capabilities. The SAML defines the XML based assertions and protocols, bindings, and profiles. The term SAML core refers to the general syntax and semantics of SAML assertions as well as the protocol used to request and transmit those assertions from one system entity to another. This protocol refers to what is transmitted, not how it is transmitted. A SAML binding determines how the SAML requests and responses map to standard messaging protocols. An important synchronous binding is the SAML SOAP binding. This standardizes queries for and responses that contain user authentication, entitlements, and attribute information in an XML format. This format can be then used to request security information about a principal from a SAML authority. This authority, sometimes called the asserting party, is a platform or application that can relay security information. The relaying party, which may be the assertion consumer or requesting party, is a partner site that receives the security information. Now let us see about open authentication, which is called as OAuth. It is an open protocol initiated by Blaine Cook and Chris Messina to allow the secure API authorization in a simple standardized method for various types of web applications. Cook and Messina had concluded that there were no open standards for API access delegation. This discussion group was created in April 2007 for the small group of implementers to write the draft proposal for an open protocol. David Clinton of Google learned of the OAuth project and expressed interest in supporting the effort. In July 2007, the team drafted an initial specification and it was released in October of the same year. This is a method for publishing and interacting the protected data. For developers, OAuth provides users access to their data while protecting account credentials. OpenID. It is an open decentralized standard for user authentication and access control which allows the user to log on to many services using the same digital identity. It is a single sign-on, that is SSO method of access control. As such, it replaces the common login process, that is login name and a password, by allowing the users to log in once and gain access to resources across the participating system. The original OpenID authentication protocol was developed in May 2005 by Brad Fitzpatrick, creator of the popular community website LiveJournal. In late June 2005, discussions began between OpenID developers and other developers from an enterprise software company named NetMesh. Now let us see about SSL or TLS. Transport Layer Security (TLS) and its predecessor Secure Sockets Layer (SSL) are cryptographically secure protocols designed to provide the security and data integrity for communications over TCP or IP. TLS and SSL encrypt the segments of network connections at the transport layer. Several versions of the protocols are in general used in web browsers, email, instant messaging, and voice over IP. TLS is an IETF standard protocol which was last updated in RFC 5246. The TLS protocol allows client-server application to communicate across a network in a way specifically designed to prevent eavesdropping, tampering, and message forgery. TLS provides endpoint authentication and data confidentiality by using cryptography. TLS involves three basic phases: peer negotiation for algorithm support, key exchange and authentication, symmetric cipher encryption, and message authentication. During the first phase, the client and server negotiate cipher suites which determine which ciphers are used, makes a decision on the key exchange and authentication algorithms to be used, and determines the message authentication codes. The key exchange and authentication algorithm are typically public key algorithms. The message authentication codes are made from cryptographic hash functions. Once these decisions are made, data transfer may begin. Thank you.